The definition of an ellipse is that it's the set of all points whose distance is from two fixed points, and those fixed points are called the foci. That's the plural form of the word focus. Okay, so we're talking about the set of all points whose distances from two fixed points have a constant sum. So we know what basically the shape of an ellipse is. We've got two options. Either the foci are located on the x-axis or the foci are located on the y-axis. And in all of our situations, we're going to start with a center of our ellipse at the origin. So how does this definition work? Well, if we pick some point on our ellipse, some point P, and we measure the distance from P to each of the foci. So if I measure the distance from P to F1 and the distance from P to F2, the sum of those two distances will always be equal to 2a. So absolute value PF1 plus absolute value PF2 has to always equal 2a. Alright, now there are lots of important, well, a number of important points that are going to be involved with looking at ellipses. Let's start by taking a look at the equations. The general form of the equation of an ellipse that you're going to see, if we have foci on the x-axis, that equation is going to be x squared over a squared plus y squared over b squared equals 1. Now, every ellipse has two axes. Has a major axis which is going to be the length of the long axis. An axis is going to be a line that runs through the center of the ellipse. So the major axis is the distance, the longest distance across the ellipse, if that makes sense. The length of the major axis will always be 2a, and a you're going to be able to pick out from the equation. There's also a minor axis for every ellipse. The length of that minor axis is always going to be 2b, and b you'll be able to figure out from the equation. Now, if the major axis has a length of 2a, and we're measuring from the center at 0, 0 out to this point on the ellipse, which is called a vertex, then that distance has got to be a units because it's half of the major axis. So the coordinates for that point, we'll call it vertex 2. The coordinates for that point have to be a, 0. On the other side, you'll have another vertex. There are two vertices. We'll call it vertex 1. The coordinates for that point would be negative a, 0. Now, where the minor axis is important is it tells you where the ellipse crosses, in this case, the y-axis. It's going to intersect the y-axis at positive b. In fact, we could give you coordinates of that point, 0b, and this point would be 0, negative b. Similar kind of arrangement with the other ellipse. If we have foci on the y-axis, the equation is going to be y squared over a squared plus x squared over b squared equals 1. So the length of the major axis is a. If the value of a is under the x squared term, then you've got an ellipse with foci on the x-axis. If the value of a squared is under the y squared term, then you've got foci that are located on the y-axis. Alright, so we have two vertices for this ellipse as well. Vertex 1 up here at the top would have coordinates 0a. Vertex 2 down at the bottom would have coordinates 0, -a. The value of b tells you the length of the minor axis, which is going to determine where this curve crosses the x-axis, which would be b0 and -b0. Now, one thing that we haven't talked about at this point are the coordinates for the foci, for the points F1 and F2. Well, those coordinates are always going to be, those points are going to be some constant value c away from the center. So the focus F1 on our horizontal ellipse here would have coordinates -c0. The focus F2 would have coordinates +c0. And focus F1 on our vertical ellipse would be 0c. And of course F2 would be 0, -c. Now the relationship between the value of a and b that you can get out of the equation and the value c is always the same in every ellipse. A squared, well, let me write it this way. I think this is going to end up being more useful to you. B squared is equal to a squared minus c squared. It's worth noting that a is greater than b, and they are both positive. A is also greater than c, and a and c are both positive. So if the foci are on the x-axis, you have a horizontal major axis. If the foci are on the y-axis, you have a vertical major axis. Alright, so let's look at an example. Suppose I'm given the equation x squared plus y squared over 9 is equal to 1. Now it's important for you to recognize that even though it's not written, it probably wouldn't be printed in your textbook, probably not going to show up on Math Excel, there is a coefficient of 1 under that x squared term. Now when I look at that equation, the x squared term is written first, so I'm kind of inclined to think that the value of a squared is 1. Because with my horizontal major axis, that's the equation we have given where x squared is written first. Problem. A has got to be the larger of the two numbers. So since you're adding terms, it really doesn't matter what order the terms are written in. If you prefer to rewrite that as y squared over 9 plus x squared over 1 equals 1, that's fine. Alright, come on. There we go. It's certainly okay to leave it the way it is and just understand that the value of a is going to be 3. It's the square root of 9. The value of b then is 1. Now if I know a and b, that's not what I wanted, then I can think about sketching this ellipse. You really don't even have to think so much about looking at the equation and deciding is the major axis vertical or horizontal. It'll just kind of work itself out. Whatever number is under x squared, the square root of that is how far to the right and to the left you count. So I would count 1 unit to the right, 1 unit to the left. That's how wide my ellipse is. Whatever number is under y squared, take the square root of that number. That's how far up and down your count. So I know based on the fact that I've got an ellipse that crosses the x-axis at -1 and +1 and the y-axis at -3 and +3, I know that we have a vertical major axis. So I can sketch this curve. Okay, we're going to need to write down coordinates for the vertices. Vertex 1, I'm going to label at the top, vertex 2 at the bottom. So vertex 1 has to have coordinates 0, 3. Vertex 2 has to have coordinates 0, -3. And the other thing you're going to need to be able to give me are the coordinates for the foci. Now I know generally where they ought to be, somewhere on the y-axis, closer to the origin than the vertices. To figure out exactly where they are, use the fact that b squared is equal to a squared minus c squared. We've got a value for b, we've got a value for a, and we can find the value for c using that equation. So c is going to be a square root of 8, or 2 square roots of 2. So focus 1 would be at 0, 2 square roots of 2. And you could get a decimal approximation to approximate where that would belong. And focus 2 would have coordinates 0, -2 square roots of 2. The length of the major axis is 6. The length of the minor axis is 2. All right. You've also got to be able to go the other way. If I give you some information about an ellipse, you need to be able to write the equation. So we have an ellipse that has vertices at positive and -6, 0, and foci at plus and minus 4, 0. So I can start to sketch this. And I'm just going to kind of estimate where these points would be. There's 6, 0, -6, 0. So 4, 0 would maybe be right there. And -4, 0 would be about right there. So right away I know that our major axis is going to be horizontal because the vertices and the foci are on the x-axis. I also know from these coordinates that the value of A is 6 and the value of C is 4. So to write the equation, it's going to be x squared over a squared plus y squared over b squared, and we don't know that yet, equals 1. So all we've got to do is find a value for b squared and we have our equation. So b squared is a squared minus c squared, and you'll find that b squared is equal to 20. That's the number that you put in your equation.